up and over. And have out your note packets from the other day. We left off on what page was this? Have your note packets out, please. What page was this?
I think it's like 13. Something like that. The unlucky page. That was the unlucky page. Mike, you're right, it is 13.
Which one did we leave off?
13.
13? All right. Now, when we do this, should I make it so you can log in? Yep.
How do you log in? It's going to take place.
Okay. Go in, please. Log into your calculators. You have home 55. Your username is the first letter of your first name, then your last name. Password's 1, 2, 3, 4. So, what we're going to go through and talk about today are some basic algebra concepts that you all should by now be quite familiar with. Taking a look at the first one, we're going to have two functions. One is defined as f of x, and one is defined as g of x. You need to fill that in. Now, as we do out what our first example is, if you need to evaluate f of 2 and 4 times the g of 3, the first thing that you need to do is figure out what f of 2's value is. Now, with these, we'll make this hopefully clear for you. How many spots are there to input, or how many input positions are there in the f? Look at the expression that represents f of x, and how many input positions are there in the f of x? Okay? 2. It's telling you take the input squared plus 2 times the input. Now, if you're evaluating this out, obviously we're going to start off with one that's easy. So make sure, please, that you've logged in if you haven't already. When you do an input, there's more than one way that you can do it. Some of you, again, need to stop. Some of you need to be reminded again to stop working in the scratch pad. You go into a document. So go into a new document. We're going to perform a computation. We're going to evaluate out f of 2. So the first thing that I need to do to evaluate out f of 2 is on my paper. I'm going to look at what the f function is. You don't need to save that. You can always delete whatever documents are in there. Go in, and every time that we do the calculation, you're going to put a parentheses around your input. So go up, please, to where it says add calculator. Just hit a 1. Now, instead of being x squared plus 2 times x, you're going to do parentheses. And now you're going to put in the parentheses, whatever you're inserting in. So let's do parentheses, and in this case, it's telling you to do 2. So 2, then outside of the parentheses, you do squared plus 2, and then parentheses 2. Every time you would be making an insertion, you do parentheses around it, and you don't square on the inside, you square on the outside of parentheses. You would go through and press enter and be left with an 8. So if I need to evaluate out f of 2, that's 8, plus now I need to take 4 times the g of 3. So some of these you need to use the calculator, some you don't. I would go in and evaluate out g of 3. So we don't need the calculator to evaluate out g of 3. Looking at what's there, Felix, what would you get if you evaluated out g of 3? -1, then multiply that by 4. So what's 4 times the g of 3 going to be? -4. So you get 8 times -4. That simplifies down to a final answer. And Eva B, what would you say that final answer is going to be? No? What do you get when you simplify out there? No? What's 8 plus negative 4, 8 minus 4? We did here, you're talking about 4 times the g of 3.
You said 8 times negative 4.
Oh, I did? Sorry. Then it should be 8 plus negative 4. What's that going to do? Sorry. Evaluate out the individual functions and do whatever the function operations are telling you to do. Now in question B, we need to evaluate out f of 1 and g of 5 and then take the product of those two values. So looking at this, you don't need a calculator to do out f of 1 or g of 5. What is the f of 1 value going to be? Gerard, what's the f of 1 value going to be? No. We plug a 1 in to the f function. Should be a 3. Now go over and take g of 5. What's g of 5's value going to be? Lily B, what do you say? 5 minus 4, which is? There we go. Now, take the product of those two, and Tammy, what would you give as your final answer? No? 3 times 1? Now, the next one up is telling you, in the numerator, I need to evaluate out the g of 2, get a number answer, square that, and then divide it by what the f of 3 is going to be. So we'll start off with what the g of 2 is going to be. Go into your calculators if you need it. What's g of 2's value going to be? Caleb S., what do you say?
4.
And then we're going to take that number and, well, careful. G of 2 is what?
2 is negative 2.
Negative 2 is squared gives you 4. Now, in the denominator, we need to evaluate out what f of 3 is going to be. And Sam C., let us know what you get when you evaluate out f of 3. Four over 15 doesn't simplify down. That's what you're left with. Questions on those? That's just using function notation, very basic. Now, those first 3 were numeric answers. The next ones are going to be just expressions. It's telling you in question D to take the f of x and multiply it by the g of x. So Jordan, what is the f of x represented by? What expression?
X cubed.
No. What's the f of x given by?
X squared plus 2x times x.
X squared plus 2x. That's the f of x. Now, what's the g of x defined as?
X minus 4.
There you go. Now, it doesn't matter what you use to go through and get the answer. You FOIL these, first outer inner last, double distribute, whatever you need to call it. Go through right now, double distribute and combine your like terms. And let's evaluate what this expression will come out to be. And Angel, let us know what you get when you get it.
X cubed plus 6x squared.
Is that what we got? Yes or no? I thought there's something. Is this a 2 here?
Minus the 11.
Minus 2x. So when we do this, first terms give us that. The outside terms would give you a positive 4x squared. And the inside terms, oh sorry, it's a negative 4x squared, that's why. And then the inside terms would be a positive 2x squared. Questions on that? Now the next one up for E, to go forward with E, see, McKenna, what would you write out? Do your replacement. do we have to compute to get an answer in E?
You do x minus 4 times x minus 4.
Good. That's squared. And then what would you do once you got that?
You take that and just subtract the x squared minus plus 2x.
Now, as that's written, there's something incorrect about what's up there. Because you need to remember you are distributing out a -1 to that amount. The first thing that you do is square the x minus 4 or multiply it by itself. Doesn't matter how it gets done. Go through and take right now the quantity x minus 4 and square it, combine like terms, all of that. What do we get when we take the quantity x minus 4 and square it? And, yeah, what do you say?
X squared minus 8x equals
Now, I'm going to distribute out the negative, so this will be negative x squared and minus 2x. I'm going to put my like terms together. And Stephen W., what are you left with when you put your like terms together?
Minus 10x plus 6.
Questions on that? So you can do it with numbers. You can go through and do it with the expressions themselves. This next piece, there's two ways that we can do these. These are called composition of functions. And what they are, you can give it either notation. The Regents uses both. If you're reading it, you go f of g of x, or f followed by g or following g. These two notations mean the exact same thing. What you're doing is you're taking one function and inserting it into the other, or a value, insert it into a function, get an answer, and then insert it into the other. But they're all sort of chained together. So when I'm doing this out, the first one up, it says that's my f of x, and this will be my g of x. We need to evaluate out what a and b are going to be. These start from the inside and work their way out. So to begin with, I'm going to start with the 2. In this case, since it's a number, start with the 2 and go to the left. I'm going to plug that into the g. So I'm going to evaluate out g of 2. So based on what the question is, what is g of 2's value going to be? Jake, what do you say?
4.
I'm going to then take that 4 that I got in the answer and plug it into the next function going to the left, which would be the f. So I'm going to go through now and evaluate out f of 4. So Rebecca, what would you say the answer is if you evaluate out f of 4?
It would be 9.
And you're done. You start with the inside and go to the left. With that in mind, what would we do, Michael, to start off b?
It would plug in the 2 thing, x and f of x, and you get 5.
Okay, so I'm going to evaluate out f of 2, and when I do, I get out a 5. And Teresa H., what would you do next? Now, give me a g of 5, and I get 25. Is this commutative? Does the order matter? Yeah. So is the composition commutative? We would say no. The order matters. Questions on that? All right, let's bounce over. Now, these are just a little bit different. We're going to avoid this piece here where it says check using a number value. We need to go through, and now you're working with an expression. Here's my f of x, and here's my g of x. Same f of x, same g of x. So when I'm doing this, I'm going to take one function and insert it into the other. When I take this and I start, here's the inside function that gets put in all the input spots on the outside function. There's not a number this time, so our answer is going to be an expression. So I'm going to take the g of x and plug it in for the input spot in the f of x. This is my g of x, right? It's got to go right into that spot right there. And if there's operations to do to simplify it, we will. So this is going to be 2 times my input plus 1. In that input spot, I'm going to put and insert the x squared. So if I were to simplify this down, Mike, what would you give as your final?
F of g of x equals 2x squared plus 1.
Perfect. Now, there's 2 ways that you could give this. You could say f parentheses g parentheses x, or you could also go through and give it out as, it looks like you're writing 5 f of g of x. They both mean the same thing. You take one and you insert it into the other. Questions on that one? Let's try going the other way. Which function is getting inserted into the other in question B? What do you say? Which function is getting inserted into the other in B? So what is that going to look like if I take the f of x and plug it in for the input in the g of x?
2x squared plus 1 squared.
Careful. I'll do 2x plus 1 squared. Because this on the inside, remember telling you take the input and square it? So I'm going to take that and slide it and put it into the input spot. Right now, you all are going to go through and FOIL this, first outer, inner, last, double distributed, whatever you want to call it. What do I get if I take the quantity 2x plus 1 and square it out? You need to go through and give the rectangle a fun, that's fine. Whatever it takes, just make sure you get it done. Did you get it? Let's hear it.
For x squared plus 2x
Close. You should have gotten the 2x twice. That's what comes together to make that. Questions on that? All right. Now, and this, I don't know why this causes some of you to panic so much. For the first one, people shut down when they see this, and I'm not exactly sure why. That's my h of x. How would I evaluate h of negative 3? Spencer, what would we go through and do? Okay, so what number would you get when you took h of negative 3? Okay, what would you do next? Yeah, so h of negative 10, and what would your final answer be? Final answer. You just do the same thing. You plug in a number, get an answer, then plug that new answer in to get out your new final answer. The next one up says take h of x. Well, this one again gets a little bit awkward, but not too badly. You need to take h of x and insert it into h of x. You can tell me what that expression will look like before I do any of the simplifying out that we need to get done. Take the h of x, plug it into itself. What would it look like? We got 1 person, 2, 3. Want to give it a go? 3 times my input minus 1, and that inserted function is 3x minus 1. So now let's simplify this out, combine like terms. Lauren C., let us know what you get when you distribute out and we combine all of our like terms together.
9x times 4.
Questions on that? Yes.
Why did you put the 3 in question?
This right here you're asking about? Because in terms of the function, this is 3 times the input minus 1. So whatever goes in here, you could have a y. It doesn't matter the variable selection. It's saying that you use h of x because that's your input. So any other expression would have to get put in here. Okay? Just like if you go through x squared, in reality, what you're saying is take your input and then square that. Questions on that? Let's go. We'll save this one. Take a look at question 7. We have an h of x and a g of x. We're going to work our way through. Hopefully we can finish. Bounce over, please, to question 7. This is the f of x that the question is referencing. And here's my new g of x. Looking at what's there, the first thing I'm going to do is take f of g of x. So, what would that, well, let's start off. If I take f of g of x, Olivia C., which one is getting inserted into the other? Is the g going into the f, or is the f going into the g? Okay, so what's it going to look like if I take the g and insert it into the f? What expression would I have? Hang on, you said something in there that wasn't right. What did you say was? You said the square root of what? Just an x plus 2. Because remember, here's your base function. Under it, you have an x or an input. Now the other function slides into that input spot, and you would just be left with. Now, to figure out what the domain of this is going to be, and there's more than one way, I guess, that we can deal with what the domain is. Go in right now, please. Graph it in your calculators. Go in right now, please, and graph this in your calculators. Looking at that now, you should be able to comfortably answer what your domain is going to be. Hands up, please, if you can tell me what the domain on this would be. We've got 1, 2, 3 of you, 4, 5.
The square bracket, -2, and then plus infinity, parentheses.
If you were to sketch this graph out, you would give a set of x, y axes. We've got -2, and it shoots up something like that. To proceed forward from here, and by the way, you would be expected to at least label where the x-intercept is, since it occurs at a lattice point or an exact x-y crossing. So this would be the point -2, 0. It's a little, at least for tomorrow's stuff, we list out coordinates, and a lot of you guys struggle with listing out coordinates. So make sure, please, that we understand that that's what we've got. What is the range on this going to be? Felix, what would you say the range is? So, and what gets put at the 0? We went over it before. Hands up, please, if you can tell me what the name of the expression under the radical is. Radicand, then you have a radical sign. We talked before. Dr. Welker came in and was saying that I yelled about them not, that somebody went back and told him that he didn't use Cartesian plane. And he came back and he goes, oh, apparently you were yelling Cartesian plane. And I can assure you, no matter how good he thinks he is, I can always get one. Now, here's another one you can yell at. When you graph on the Cartesian plane, see how the point -2, 0 occurs exactly at one of those sort of imaginary crossings of lines? You know how when you're looking at the Cartesian graph, it looks like it's a fence, right? If it occurs at exact integer crossings, do we know what that's called? A lattice point. Okay? So, like lettuce, except with an A. So you can yell at him for not teaching you what lattice points were also, because that's the proper name of those. If it crosses, you look for lattice points. That makes doing the graph very easy. Like the point 1,7 is a lattice point, where like 1 and 6.5 wouldn't be a lattice point. Let's take a look now and go the other way. which function is getting inserted into the other and the one on the right-hand side. Deanna, what's that going to go through and look like? Which function is getting plugged into the other? Let's ask that first.
X is being plugged into G of X.
Okay, so I'm going to now take the f of x function and insert it in for the variable position in the g of x. So what is that composition going to look like?
The square root of X plus 2.
Oh, and I did, maybe on a test or a quiz or something graded, you would be expected to state that g of f of x. And this one over here, we might as well tighten up. Shrink it down. So we go through and say that this is the f of g of x. Now, looking at what's there, without going into the calculator, who can tell me what the domain on this expression would be without going into the calculator and why? You've got to be able, as an enriched student, to be able to restrict the domain, and hopefully we are smarter than the plastic that we hold. What would our domain on this be? We just have 1, 2, 3 of you? Do I give it a try or not? Give it a try. I'll yell at somebody else. Okay? No? Because think about it. Can you plug in a -2 in for the x and get an out? Yeah. We got 3 of you. What do you want to say? Why did you start at 0? You're right. In the? Yep. It's going to be 0 to positive infinity, because the values that I can plug in, I can't plug in a -1. Could I plug in a -1 in the other one on the left? Because that still is going to leave me with a positive radicand value. Now, we need to look at the range of this. Now, what's the smallest x value, before we go into the calculator? Maybe some of us will be able to get what the range is without it. What's the smallest x value I'm going to be able to plug in and get an output? 0. But 0, when you take its square root, plus 2, 2. So what do you think your range then would be? 2 to positive infinity. So let's go through now and check to see if that in fact is true. Here's your Cartesian plane. Let's see. Square root of x plus 2, so I'm going to shift up 2. And then give that graph. The lattice point that this would go through is the point 0, 2, not 2, 0. Questions on that? Is that what the graph in fact looks like? Yes or no? Is that what we got? Terrific. Terrific. Now, who here, let's start off with this. Who here has Mrs. Capalla as an English teacher? Only 5, 6 of you? Okay. I will say this. Mrs. Capalla, Ms. D'Angelo, Ms. Morenzi, and myself get together for dinner like once every 2-ish months. I've seen this happen firsthand. You wouldn't. It almost seems like it's mathematically impossible. Mrs. Capalla is the queen of Coles. The queen. No one. Who here has a parent that shops at Coles? When they go in, why do they go to Coles as opposed to someplace else? Sales. Sales on top of sales on top of sales. We've been in there before, and she gets them on the phone. She has them in her hand in like a print newspaper or something like that, and there's specials. We walk in, and you go, there's a sale. Now again, I don't know what kind of business model this is, but I don't know if you've ever paid full price at Kohl's. You may be just the dumbest person ever. Because I don't know of any time that they're not having a sale on everything. And it's not even like it's a minor sale, like 5% off. They'll have sales that are literally like, say 50% with a 20% coupon and 40% off of that. And you have people who sit there and are like, what? Like, what even? It would only make sense. They could only make money if the original price was like $1 trillion. Like a shirt was $1 trillion. So you take 90% off of that, was 40% more off, and then a new car. So, my mother is this person. She goes through, and it used to be before there were Kohl's, she would go to JCPenney's before they actually changed their coupon policy and people got out there. But they would go through and they have these compound sales. So this one up, you go in, Macy's actually still does this too. It was on sale for 30% off and 40% off with a coupon. They told the friends, this means I get 70% off, the coat's only 30 bucks. They get to the register, that's not in fact the case. Does anybody, can you explain why that's not the case? What do you want to say?
30% off and you finally I put in my system.
Perfect. They program this to be a nested or composition function when they put it in the computer. Now, this is one where your Algebra 1 teachers may not have done the best job. What is a function? If the price is X, what do I have to do to get the answer from the, or the final price, the sale price of this coat? Hands up, please, if you can tell me. If you're just factoring in the sale, what function models the sale price? 2 of us, 3? My father, when I was growing up, used to do this in the car. When he yell about my mother not understanding sales. You want that? 0.7 times X. You multiply it by how much remains. So my sale price would be 0.7X. Now, hands up, please, if you can tell me what the coupon price would be as a function. We got 1 person, 2, 3.
0.4 times the quantity of 0.7x? Or 0.6.
0.6. Now, it doesn't matter. In most cases, depending on what the operation is. In this case, it won't matter. When you do it, and they always say, the way that Cole says it, it says, and you'll see it on, it'll be like 70% off and take an additional % off. That means that the first one that they're mentioning in the commercial is the one that they're doing first. In this case, you always take the sale first, so it would be S, then the coupon of X. So I go through and plug the coupon into the sale function. So it would be 0.7 times 0.6X. I took one and plugged it in for the other. Now, in order to get out our answer here, I need to go through and simplify this down. I love how many of us need to go to the calculator. This was what was so disheartening. I don't know how we made it, and we're Algebra 1 honor students. 0.7 times 0.6 is not something we need a calculator for. Hands up, please, and you tell me what 7 times 6 is. Yeah. 42. And how many spots do I need to slide that over then? 2. So it's 0.42 times X. Now, we're going to bounce back for a second. Have your homework from the other day out on your desk. Now, there was one question that was on here. I didn't give you the worksheet to go through and do. But one of the things that was rather disheartening when I was doing it, and to be honest, the one thing that's the big sham is you all need to understand that it's you. This course is not a reflection on me in the least. It's truly a reflection on you. And you get out exactly what you put in. And there are some amongst us who just, the minute that it gets difficult, you shut down. You go, well, I haven't done, this is not, we call them regurgitators. If you see something, you can do it 150 times. And if it's moderately different, sometimes people shut down. You've got to be willing to take that first initial step. From your homework, there was one question I thought was difficult. One. Which one do you think, out of this grouping, was the difficult question? Hands up, please, if you can tell me. It was probably, hopefully, the one that made you think the most, and the one that took the longest amount of time. Which one were you going to say? Yeah, I was going to say 6. So go through right now in that packet and read what it says for question number 6. Because allegedly, you all did phenomenal on it. Some people go through and ask questions. 6 was the one that I got the most questions on. It talks about some stuff in there. So hands up, please, if you can read through, or tell me. Hands up, please, if you can tell me what information you need or what it's asking you to do in question number 6. Allegedly, you all did your homework from what I understand. What would you want to do? Yeah. What's the information that you think is important from that? Okay, so I'm going to look to sort of create a relationship here, and you said 55 gets matched. 55 is the output when you start off with how many? Was it inches or something like that? Okay, 1 square inch corresponds to 55. You can tell me something else that would be some important information there.
The other relationship, 4 inches.
And that gets mapped to? Okay, and we're trying to figure out, was it 3 we're trying to figure out what the grass is? So 3 then would get matched with what? Now, the one thing, again, that you all have to become more comfortable with than you are is being a problem solver. Because there are some out there who literally go, yeah, I can't do it. Well, fine. But this is an honors class. Like you're expected to retain and go above and beyond. The ones that, most of this packet is the same stuff that I give to the Regents. The word problems or the extending problems are the ones that we hope that you spend some time with. And I want you not only to do them, but I want you to do them and get them wrong. That's the point. I want you to try and experience the failure of it. Do it and have it not work out. You're not supposed to get all of them right all of the time. You would be like in the 99th percentile for intellect if that happened. You have to get comfortable with saying, this is different than how I've done something before. It's not telling me everything that it needs to do like I'm 3. This is going to be awkward. How would you go about figuring out what would happen if we did the 3? Give it a try. What do you want to say? Go ahead.
I took 55 and then had that over 1 and then 230 divided by 4. And then
Okay.
the difference is what that would be divided by 3. And then that came out to be 5, 6. And then I added 2 of that to get 3. And it came out to be 170.
170?
No,
What answer did you get?
57 and a half. And you have to multiply that by 3.
Okay. I'd say that's pretty close to being on your way. And did you get your final answer to be 172? No. Because I think you might have truncated it along the way. Oh, or maybe you didn't take into account, there's an initial condition as well. We'll go over how to do it. You're not that far off, though. You used a proportionality effect. Yeah. Okay, now, the first thing that you did is I'm going to say this is a linear relationship. As it gets bigger, the number of blades per graph, that ratio is going to remain the same. So your slope would be constant. And you said that your slope when you did this came out to be how much? 175. Now, this is one thing that does, I don't want to say it because I don't want to misconstrue it and have anybody take it personal. When you do outlines, the y equals mx plus b part is not used much after geometry. And I know that they beat that into you in like 7th grade up until 10th grade. I asked Mr. Welker yesterday if he showed you the y minus y1, and allegedly he did. See, the problem is this. Now, whether they did or didn't at this point, I really don't care. We just need to make sure that you can. So, get past the y equals mx plus b because it's constraining. You can only use that if you have the b. Do we have a y-intercept here? No. And then say, well, I can go through and solve it, and I can go. Oh, stop. You don't need to if you have this. Use this every time. This is the one that they should have been teaching you back at Sprott. They don't because they're not as smart as I am. Now, if I use this, I have a point on the line, and I have a slope, and I can use it to find more points on the line. So, which of these points on the line would I want to use? Stephen, you get to pick.
Wait, which point?
Yeah.
4.
4 and what? No, the point on the line. can tell me which one, yes. Or, yeah. So now I'm going to plug that in. So I say, here's my line that models this situation. So 4, let's say let's do the 4 and 230 because you freak out when the numbers get there. So this is 175 over 3, and this would be x minus the x of 1 would be 4. Now, that's the line that models this relationship. We need to solve this out for the y when the x is 3. How can I use that equation to find my y if I know what the x is going to be? Yeah.
Just plug in the x
Of
3.
So I'm going to go y minus 230 is equal to 175 over 3 times, in this case, my x was 3 minus 4. This is a number value. So go into your calculator and type in 175, and everybody do it. Go in right now, type in 175 in parentheses on the outside, getting distributed to the quantity of. And when you have a fraction, you hit control division to make that show up. Oh, we don't need to save documents ever. So go in and make a new document. Don't save it. Now we're going to add calculator. So control division, 175 over 3 to the quantity of, was it 3 minus, what was it?
3 minus 4.
3 minus 4, all right. So when we're going to get a number value, right? Now, I've got y minus 230 is going to be equal to, this ends up being negative 175 over 3. What do I need to do in order to solve?
Add 230 to both sides.
So let's add 230 to both sides. So again, the calculator handles these big numbers wonderfully. So you're going to get y is equal to, so go through and take that amount and hit plus 230 and hit enter. Now, that's what we get. And some people are going, well, all right, well, that's the answer. It's not the answer. Put that as, see what that comes out to be. And what was it? I'm sorry, was it 530 over 3 or something?
513 over 3. Or 515.
Over 3?
Yeah.
Now, and another thing, some of you are doing mixed numbers. I don't know, we don't do that anymore, ever. So never give a mixed number like 1 and 2/3 or something like that. That never is an acceptable answer. We get 171 and 2/3 blades of grass. So how many blades of grass would we expect to find? 172. We would round up. So we'd say approximately 172. Now, when we start talking, again, to give you some perspective, like if you're, let's say you go to work right for NASA, is it always going to be integer lattice points that you're going through and using? Or do the numbers sometimes get awkward? Decimals happen, but you have to be a problem solver. That's the part from my end. I don't know if did all the questions that you did before, did they work out nicely? Or did they get messy at it?
Sometimes they got messy.
All right. So a lot of the questions that we do, hopefully every night you at least have one on the homework. They're supposed to get messy. I'll give you what the answers are, and if we have questions on one, this is why I did number 6 with us in class. It's a good discussion to go through and have, and that's why when I was talking about yours might be off slightly because there's a y-intercept initially, and then it grows at that. What did you say that the ratio was? Like 57 or something? 57 and a half?
Yeah, and the slope of this, if you simplify the 175 over 3, comes out to 58.3.
Okay, so it's an approximate thing. It's off by just a little bit. But again, there's more than one way to do a lot of these questions. I had somebody who actually just plotted it out on a graph and then drew the line through those 2 points and found where 3 was and says this would be about 172. Is that wrong? No. I applauded them for connecting it to something that they already knew. But we have to make the connections. The part, if anything, that we get you to do out of this year, stop being, you get nervous when you get to a question. Again, if you're going to fail and get it wrong spectacularly. Don't miss by a little. Miss by a thought. Miss by 1,000. A factor of 10. A factor of 1 billion. And own it when it happens. Oh my! And then you get an answer, and somebody in the other class got. They go. It came out to 4,000,008. at some point you should say 1 goes to 55 and 4 goes to 230. Does my answer fall somewhere between those? Is that a lot of graphs to have? Yes. But you know what? They owned it and they failed spectacularly. You give me something. I can work with, you miss it. What I can't work with is when they say, I don't know what to do. Show me something related to a prior experience. Go out in the grass and count. Say, I can fit 55 in here, 230 in here. You're right, 3 is about 6 million.
Interruption.
Okay? Now, your homework tonight is to go through ants.
Soccer players, boys, freshmen, soccer players. Practice today will begin at 4 o'clock.
You've got questions on 3 to go through and get done. Was tonight's homework 3, is that right? Yeah. 3, make sure it gets done on separate paper. Some days we have somebody that also started yelling. Well, are you collecting? Some days I collect it, some days I don't. I had lunch duty the other day. I'm walking through and watching 2 people do my homework over their shoulders. When they go, hey, wait, I'm watching you copy the homework. Is it really the most authentic learning experience? Probably not.
My devil's advocate with that last question.
For what?
10, 8, 3.